We're going to be learning to use our calculator and doing some review of some calculator work we've already done when we're working with trig functions. So some of this will be a little bit of a review. Something that we've looked at before was converting degrees and minutes to decimals. So an example where you could use your calculator, you could find the sine of not just a standard angle like 30 degrees or 35 degrees, non-standard, but one with degrees and minutes. So the way that we would do this is we could convert it to decimal. That's one approach that we could take. Or we could use the degrees, minutes, seconds on your calculator screen. So first of all, let's go ahead and look at converting this to a decimal. That would be one option if you don't have the degrees and minutes. So if we convert this to a decimal, this would look like 32 degrees plus 12 over 60 minutes. So 12 over 60 is 1/5, which is 0.2. So this would be 32.2 degrees. So this is equivalent to saying the sine of 32.2 degrees. So let's go ahead and pop our calculator over. And I'm using the graphing calculator as usual. If you have a different calculator, of course, you're welcome to use that. You see here. And scoot this over a little bit. So the way we did this is we did 32 plus 12 divided by 60. And that's where the 32.2 came in. And so what we can do now is we can find the sine of 32.2. Always close that parenthesis up here. And I'm going to get the wrong answer, but let's go ahead and hit it and see why. Now the reason this is the wrong answer, the sine of 30 degrees is about 1/2. So this seems like it's a little bit too big. What I'm looking at up here where it says normal, float, auto, real, radian, one of the most common mistakes you can make is your calculator will be in the wrong mode. We need to be in degree mode because we're working in degrees. We haven't even ever worked with radians yet, but when we do work with radians, it's a totally different mode on your calculator. So the way that we switch to degree mode is you click mode, and then if you look right here, you see the normal flashing, but if you go down to radian, and you come down here to degree, we want to switch it over to degree and hit enter. Now notice at the top now it says degree. So let's go back and recalculate this. Let's go to sine 32.2. Should be a little closer to 1/2. Yep, 0.5328. So here we get 0.5328. Now when you do these problems, they'll tell you how you want us to round. I think this one wants us to round to like 8 or 9 places. So let's take this out quite a ways. So this would be 0.5328762761. So if they want us to round this to 8 places, this would be 1, 2, 3, 4, 5, 6, 7, 8. So we go to the 9th place and it's 5 or above, so we'd round this up. So this would actually round to 0.53287628 rounded correctly. Now let's go ahead and enter this as well using the degree minutes option. So we want to put in 32 degrees. The degrees is under this angle, so that would be second apps. That gives us our degree here. And then we need 12 minutes. So we go to second angle again and enter the minutes. And then we close those parentheses, and we are in degree mode. It should stay in degree mode once you put it in degree mode until you switch it. And you can see that we get the same answer for both ways. So you can convert it to a decimal or enter it using the degrees and minutes. We get the same answer either way. So that's really nice because if you notice here on our calculator, we have sine, cosine, and tangent. We do not have secant, cosecant, and cotangent. So what would we do about a problem like that? So let's look at an example where we'd have to use some different options. Let's use green. Okay, let's look at secant of 44 degrees in 18 minutes. Now again, we could convert this if we want to, same as we did before. We could convert by using 44 degrees plus 18 over 60 to get a decimal approximation. And we'd have to be really careful here. We really wouldn't want to round much. So let's look at 44 plus 18 divided by 60. 44.3. So I guess that's not, we don't have to worry about rounding too much here. One thing I want you to be careful of is if we were to go and take, let's say this was 44.3739467 or something like that. If we over rounded that, that's going to throw off our answer. So we don't really want to round this at all if we can help it. So let's go ahead and look to see how we could enter this in our calculator. So whether we enter it with degrees and minutes or with our decimal, we don't have a secant key on our calculator. So we need to remember that secant and cosine are reciprocals of each other. So this would be 1 over the cosine of 44 degrees 18 minutes. This would also be equal to 1 over the cosine of 44.3 degrees. So the way we can enter fractions, of course you can do the 1 divided by. What ends up happening though is once we start to get several terms, we have to be really careful that we don't have something in the wrong spot. So let's say we had 1 over 2 plus 3. Is the plus 3 in the denominator, or is it 1 over 2 and then I add 3 to the numerator? That's not clear. So to make it easy, we can use our alpha y equal key, and I have a fraction button here. And so then I can clearly see what my numerator and our denominator are. So here I go 1 over cosine. Let's do 44 degrees. And again, that's second angle. There's our degree. And 44 degrees, 18 minutes. And then minutes would be second angle, and then 2 would be our minutes. Close parenthesis. We're in degree mode. I always check up here. So I get 1.39724, etc. Let's try it with our fraction as well. Alpha y equal, numerator over denominator. Let's use our decimal. 1 over cosine 44.3. Remember, I'm in degree mode. Always check that. And you can see that we get the same for both. Okay, so for both of these, we get the same answer. We get 1.397247664. Same for here. And then our directions for here, I believe, are to round to 8 places. So always read through those directions. So if we round to 8 places, we don't count our number to the left of the decimal because that's a whole number. We count our decimal spots. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So if we round to 8 places, I look at the 4. The 4 is not 5 or larger, so I keep it the same. I keep the 6 the same. So the secant then of 44 degrees 18 minutes would be 1.397247766. Yep, I have my 8 decimal places there. So using that fraction key is going to be helpful. If you don't have a fraction key, you can use your 1 divide key. But again, be really careful with that because sometimes when we get to more complicated expressions, I might have my parentheses in the wrong place and it might not evaluate correctly. So get used to using that fraction key. It'll be really helpful for you. Now we're going to get into this conversation a lot more in depth a little bit later, but let's look at a question that you might run into where you're asked to find an angle given a trig functional value. So for instance, we might just ask to say something like find a value of theta in the interval and let's go 0 to 90 degrees here. That has the sine of theta equal to 1/2. Well, because we have our trig functions memorized and their values for the standard angles, the quadrantial angles, and the 30, 60, and 45, we know that the sine of 30 degrees is 1/2, and 30 degrees is in this interval, so I would say theta equals 30 degrees. Now, there's no other angle between 0 and 90 degrees that has a sine equal to 1/2 other than 30 degrees. So that's the only possible value. Now, what if it was a non-standard angle? It wasn't one of those special angles. Or what if I couldn't remember what it was? Well, our calculator gives us a way to solve these. And the symbol that it gives us to solve these is inverse sine. It kind of means to kind of like do the opposite. It means what angle. Okay, so inverse sine means what angle. So what I do is I take the inverse sine of both sides. And there's really a lot more to this. I'm surprised that the book introduces this so soon. But because they do, we'll make sure we look at it. We take the inverse sine of both sides. And what happens is this means what angle has a sine of theta. And the response there is theta. So if you want to think about it as the inverse sine and the sine canceling each other out, you could think about it like this. Now this over here on the right hand side means what angle, and of course they gave us the interval here, in 0 to 90 degrees has a sine of 1/2. And again, because we have our special angles memorized, we could just say, oh, that's 30 degrees. That's my answer here. Well, what we would do on our calculator, because most of these will not be standard angles, we would just put in the inverse sine of 1/2. And again, inverse sine, sometimes you're used to seeing like this notation, like x to the -1 means 1 over x. This means to reciprocate. X to the -1 means to flip or reciprocate. This does not mean, and this is really important, this does not mean 1 over the sine of 1/2. So no, don't ever do this. Inverse sine means what angle. Okay, it means what angle has a sine of 1/2, and they give us that interval to look at. So what we would do is we would put inverse sine into our calculator. And I'm going to do that up here so we don't have that on the page. So let's go ahead and pop our calculator in. And let's find our inverse sine. Our inverse sine, or arc sine is another name for it, is above our sine function. So we go secant inverse sine, and we put in our 1/2, 1 divided by 2. We're in degree mode, and hit enter, and we get 30 degrees. Another way we could do that is do our secant inverse sine. We could also do our alpha y equal for our fraction, and we could put our 1/2 in this way as well. Sometimes our expressions inside that argument are going to get a little bit more complicated, so using the fraction key might be helpful. But either way, we get 30 degrees. Okay, so this would equal 30 degrees. But again, it's important that you be able to kind of think about these and think on your feet a little bit, instead of just always going for the calculator. So knowing your trig functions with those standard angles is going to be important. Let's look at another one. Let's look at, let's do tangent. So we want to find theta in the interval, and let's do 0 degrees to 90 degrees. That has a tangent of theta equal to, and we have a long decimal here because we want some accuracy. So let's do 805.04525. So this is not a tangent I recognize. I recognize things like square root of 3, square root of 3 over 3, 1. So this does not look like to be one of those special or standard angles. So the way I would solve this using my calculator is I would take the inverse sine of both, or sorry, the inverse tangent of both sides. And on the right hand side, this is asking the question, what angle has a tangent equal to 0.80504525? Now over here on the left, the inverse tangent and the tangent, you can think about them as canceling. And let's see, let's get to our calculator. So we need to find our arctangent or inverse tangent, and it's above the tangent key. So we go secant inverse tangent, and then put in that decimal, 0.80504525, and close parenthesis. And we're in degree mode, so I get 38 point, let's write this out, 8356 381 degrees. Okay, now they're going to ask you to round it to maybe 6 places or 5 places. You'll have to double check to make sure that you have the rounding correct. Let's go to 6 places. So there's 6 places, so I look at the 7th place. It's not 5 or above, so I keep it as is. So theta would be 38.835638 degrees. Okay, so that's a way I could work with this. Now, what about secant? We don't have a secant button on our calculator, so how would I do a problem like that? So let's go ahead and say, let's find theta in the interval, and let's do 0 degrees to 90 degrees. Always look at the interval, it could change. And let's do with secant theta equal to 1.5123008. Okay, well, the way we would usually look at this is we would think about this as the inverse secant, but I don't have, if we look over here on our calculator, I do not have an inverse secant key, so how could we solve this? So in order to solve this, what we want to do is we want to think about the reciprocal identity. So let's go ahead and recall secant and cosine go together. So the cosine of theta in this particular case is equal to 1 over the secant of theta. And if I plug directly in, I know the secant of theta from up here is 1.5123008. So if I wanted to, I could rewrite this as the cosine of theta equals 1 over 1.5123008. And then to find the angle, I would take the inverse cosine of both sides, or the arc cosine. So the inverse cosine of the cosine of theta equals the inverse cosine of this fraction. Now if you wanted to, you could find a decimal for this, but you wouldn't want to round it at all. So I think it's probably better just to plug this in. So over here, remember the inverse cosine and the cosine cancel each other out. They undo each other. So on the left, I'm left with just theta. Now on the right, let's see what we have. So here I'd have the inverse cosine, so secant cosine would be our inverse cosine. And then I'm going to use our fraction key, alpha y equal 1 over, and then on our denominator we have 1.5123008. Arrow out and put in our parenthesis, and I get 48 point, let me make sure I get all these down, 605.17498. Now the directions might be to round to 4 or 5 or 6 places, so make sure that you read the directions carefully to make sure you get the rounding correct. And so let's say this one's asking us to round to, let's do 5 places. So 1, 2, 3, 4, 5, and then this 4 would not change the 7, it would keep it as a 7. So my answer then would be theta equals 48.60517 degrees. Okay, so we just had to use this identity up here, that cosine is the reciprocal of secant, and then what I can do is rewrite that in terms of cosine with 1 over the value, and then use my inverse cosine key. Now again, they only wanted us to find angles in 0 to 90 degrees, and this is in 0 to 90 degrees. So that worked out perfect. Okay, toward the end of this section, you'll be working some story problems as well, using your calculator and using this idea of the arc sine sometimes, or arc tangent, or just plugging directly in. So let's look at one of those examples. It says when an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. This force, F, in pounds, is called grade resistance and is modeled by the following equation. Now here theta is the grade, W is the weight of the automobile. Now remember, F is called grade resistance. So grade resistance is F. Okay, so let's go ahead and just plug into our formula. So we're looking for F. W is the weight of the vehicle, so that's 2,900 pounds. Sine of theta. Theta in this case is 1.2%, or sorry, degrees, 1.2 degrees. So to solve this, to find the grade resistance, what we would do is we would plug this into the calculator. Now remember, make sure you look up here and you're in degree mode, and you'd have 2900 times the sine of 1.2 degrees. Now we can't just put 1.2. We need to make sure that we put in the degree symbol, because that way we make sure that we have the correct value back out. So let's go ahead and do second angle, and let's choose degree. So 60.733 0.1766. Now this is not degrees. Okay, this is the grade resistance. Now I was just curious, and so I typed this in without the degree and I got the same thing. And that's because I'm in degree mode, but I think it's important to always make sure that you put the degree in, just to remind yourself to double check that. So even if you didn't put it in, you'd get that correct as long as this was in degree mode. Okay, now directions on here say round to the nearest pound is needed. So the nearest pound would be right here. So what I would do is I'd look at the digit past there, which is a 7. So since this is 5 or higher, I'd round that to 61. So this would be 61 pounds. Okay, so that's simply just plugging into a formula. Let's go ahead and look at one more of these, and then this is kind of a shorter section than usual. You can get started on your homework for this. So on this one, it's the same setup, it's the same type of problem, but they give us some different information. So on this one, they say when an automobile travels up or downhill, just like they did before, they still give us grade resistance, okay? And that's F. Theta is the grade and W is the weight. So if we look at this, they're giving us a grade resistance. So in this particular case, the grade resistance is F. This is our weight, and we are looking for theta. This is what we don't know. So if we have F equals W sine theta, F in this particular case is negative 160 equals 2860 sine theta. We don't know what theta is. Theta is what we're trying to find. So what I want to do with this equation is I want to solve for sine theta. I want to isolate sine theta. So if I do that, I end up with sine theta equals negative 160 over 2860. Now I could reduce this fraction if I wanted, but I'm just going to leave it as is. And then what I would do to finish this is I would take the inverse sine of both sides. Now the inverse sine and the sine undo each other. They cancel each other out if you want to think about it that way. And on the right hand side then, I would put in arc sine or inverse sine. That's the second above the sine key. And then I'm going to put in my fraction key, alpha y equal. And you can put the negative up top or out front. It doesn't matter which one. So I'd have 160 over 2860. Arrow out, close parenthesis. I'm in degree mode, and I get negative 3.207. Okay, so now under my answer box in my math lab, this particular one says round to the nearest hundredth is needed. So let's go ahead and do that. Let's round that to the nearest hundredth. So if we round this to the nearest hundredth, this is tenths, this is hundredths, so I'd go to the thousands place, and that would round this up to a 1. So theta would equal a negative 3.21 degrees for my grade. Okay, so this is kind of a short section. If you have questions, please let me know as usual. Main thing here, make sure that calculator is in degree mode.